So guys, now we are working on question number 11 of exercise 11C. The question says that A, B, C, D, E, F, G is a regular heptagon if AB and DC are produced to meet at H. Find the value of BHC. So as it is saying heptagon, the word heptagon here is used. Heptagon means hept means seven, hepta means seven, and gon means sides. So that means a shape which has seven sides. Like it can be of any dimension, but what matters is that it should have seven sides with it, and it should be a regular polygon. So first we are making a heptagon. I just made it. You can see. Here it is. A regular heptagon, I just started naming it as from here A, B, C, D, E, F, G. It doesn't make any difference like if you start from here or here, it doesn't make any difference. It is entirely up to your choice. Then it is saying in the question that I have copied the question here also. Find the value of BHC. BHC. So if we need to find out the value of BHC, for what, but before forming BHC, it says if AB and DC are produced to meet at H. Like as we discussed it earlier also in the last exercise, that whenever it says that if AB meets to make H, or if AB meets, or any other edges like CD meets to form J. So what we do, we just, it means that they're talking about this concern. Like if it is a triangle, let's suppose this is A, this is B, and if they say that AB meets to form J, that means this straight line is carried forward and this part is J. So in our case, it is saying AB and DC are produced to meet at H. That means AB and CD, that means CD, are produced to meet at H. That means this is the point H. H. Find the value of BHC. If it is not clear here, you can look it over here. Find the value of BHC. So let me tell you this thing again. It doesn't make any difference. Like if you start A from here or here, no problem. The angle will going to shift, but you will always get a triangle or this sort of collision, because wherever you form it, you will definitely get two lines and they will surely going to meet at a point. So you will always get this point H. So they're asking us to find out the value of BHC. BHC. Since the cap, you can see it over here also, since the cap is on H, this cap, that means they're talking about angle H. BHC, that means this angle. We need to find out this angle. So the problem is, like, we don't know the value of this angle, neither this. So how can we find out the value of this? So in order to resolve this issue, what I thought, that if we find out the values of the interior angles individually, like if we find out this value, if we find out this value, in short, if we find out the value of the size of each interior angle of this regular heptagon, that means we will come up with a value which is same in all the sides. The value of angle will be same in all the sides, and we will be done with the inner part. Then we can do something with the outer. Until and unless we don't know the value of the inner part, we cannot do anything with the outer stuff. So in order to find out the value of each interior angle, I use the formula we discussed earlier also, and we practiced this formula a lot. It is like n minus 2 into 180 upon n. N is again the number of sides, the edges, minus 2 of the formula into 180 upon n. Since it is a heptagon, so number of sides will be 7 minus 2 into 180 upon 7. 7 minus 2 is 5. 5 into 180 is 900 upon 7. Upon 7 is of the denominator, and after resolving this whole part, you get 900. Then moving further, 900 divided by 7, you get 128.57. Since we are taking the values till one decimal place only, so 128.57 can be changed to 128.6. Since we are taking one decimal place and this value is greater than 5, it will carry 1 to this, it will transform to 6. So 128.6 is the value of each individual polygon that we have. Like if I see over here, the value of this angle is 128.6. Again, 128.6. Now, since we know the value of these interior angles, can we do something to find out the value of this part? And if we find out the value of this part, so is it any beneficial for us? Of course it is. If we know this part and we want to know this part, since this is a straight angle, so if we subtract this angle from the 180, this whole 180, we will get this part. So we did the same. I just added these two angles, or I can do it individually also. If I subtract 128 from 180, I will get this exterior value. I did over here. 180 minus 128.6, I got 51.4. So that means this value is 51.4. Since this is 128.6, the outer value came 51.4. So same is the case will be this part also. This is 128.6 subtracted from 180, I get this 51.4. Now these both angles are 51.4 and I need to find out this h. Since this is a triangle, so as we know that sum of all angles in a triangle equals to 180, using that property, 51.4 equals 102.8, subtract it, you get 77.2. So this is how you find out